Alright, this is tape 214, and it covers the important concepts that you need to know out of exercises 1.1 through 1.5. Now let's look at some examples. Okay, we're going to start talking about points and x's and y's on a graph. So let's say we have the point 3, 4. Now what the point 3, 4 means is we're over here 1, 2, 3. So we come over this direction 3, and we go up 1, 2, 3, 4. So this point is over 3 in the x direction and up 4. So we say the x value is the 3 and the y value is the 4. So this is the y value and this is the x value. Well, we're going to introduce another letter which we will call r, and r is the radius vector. The radius vector is the straight line distance from the origin out to any point that you have on a graph. So here we have a point, and it's located by saying, okay, we can come over 3 into the right in the positive direction in the x direction, and we can go up 4 in the y direction. And the straight line distance from the origin to that point is called the radius vector r. Now, we have a relationship with that r. So let's look over here now, and we have a relationship just like we've had in other math classes called the Pythagorean theorem. And it says that that r, that radius vector, that hypotenuse of a right triangle, r squared is equal to the x squared plus the y squared. The distance OP is equal to r, and r squared is equal to x squared plus y squared. Well, x was 3 and y was 4, so we have 3 squared, which is 9, plus 4 squared, which is 16, which is r squared. And we add that and we get 25. So r squared is 25. Now, here's an important thing for you to listen to. We take the square root of both sides. The square root of r squared is r, and the square root of 25 is 5. The square root of 25 is 5. The square root of 25 is 5, not plus and minus 5. The square root of 25 is 5. Now, the answer is a positive 5 because there is a statement you must always remember, and that is the radius vector r is always positive. R is always positive. Remember that. R is always positive. So we take the square root of 25, or square root of whatever this number is, and that answer is equal to r. Positive. R is always positive. All right, let's go back and look at the graph now. And let's take the next example that we have here. We have a point Q. Point Q says that x is a minus 5. So we come out here a minus 5. And y is a plus 3. So we go up a plus 3. Now what is r? Okay. Well, let's come back over here and look at our mathematics. Okay. The distance r, or the line OQ, is again our x squared plus y squared is equal to r squared. Now the reason I write this down in the notes like that on every problem is I think that's what you should do to get where it's memorized. If you'll copy this and write it down every time you do a homework problem, then it will help you have it memorized, because you're going to use this over and over and over again in trig and other classes that require trig. All right, so we have x squared. Well, x was a minus 5. We square that, we get 25. And y was 3. We square that, we get 9. And so r squared is equal to 34. So therefore, r is the square root of 34. the square root of 34. Don't put a plus and minus in front of it because r is always positive. R is always positive. Therefore, the answer is a positive square root of 34. All right, let's go back now at the graph and look at another point, the point S. All right, the point S is a minus 2, minus 6. And again, we want to find what r is. Minus 2 minus 6 means we come over here minus 2 and down a minus 6. All right, while we're here, let's just go ahead and look at point T, and then we'll go do the arithmetic for both of them. Point T is in quadrant 4. I'll talk about that in a minute. It's over here at a positive 8 down a minus 15. All right, let's look at the mathematics now for these. For OS, the distance r from O out to the point S, again, is x squared plus y squared is equal to r squared. Well, x was a minus 2. Minus 2 squared is 4. And a minus 6 squared is a positive 36. And so we get r squared. So r squared is 40. So then r is the square root of 40. Now, that's sufficient nowadays. Now, you may see an answer in a book, or a teacher may want you to write that as 2 times the square root of 10. But understand that this answer and this answer is sufficient. They're both the same. It's just that sometimes people want it what is called simplified. Now, the way it's simplified is this. The square root of 40 is you split it into 4 times 10. You split it where one of the numbers you know the square root of. We know the square root of 4 is 2, so we get to write that as on the outside 2. We do not know the square root of 10. In other words, it's not a number that we're familiar with. It's actually 3.162, but we don't use that. We go ahead and leave it as the square root of 10. All right, let's look at T, the distance from O out to T. The distance OT is r squared is equal to x squared plus y squared. Well, x was a positive 8. That squared is 64. And a minus 15 squared, a minus 15 times a minus 15 is 225. And so then r squared is equal to 289. And so the square root of 289 is 17. So r is 17. All right, and that's explaining the concept of r. How do you find the radius vector? How do you find the distance from the origin out to a point? It is simply x squared plus y squared is equal to r squared. All right, now let's look at another graph. Now, this one is more like what happens when you use this concept of x squared plus y squared is equal to r squared. What you'll be given is the x and the r, and you have to find the y. Or you may be given the y and the r, and you have to find the x. Those processes. Now, in the textbook, or in a lot of textbooks, you'll be given things like, for instance, this example would be given x is equal to 8 and r is equal to 10. And in your quadrant 1, and again, I'm going to talk about that quadrant in a minute, but you'll be given this way. Well, then you have to go find, well, what is y? So you may be given it in these terms, where you're given 2 of the 3 letters, x, y, and r, and you have to find the other one. So let's look at this first example. At point A, we're given x is 8 and r is 10, and we want to find y. So let's look at the arithmetic then. So we write down x squared plus y squared is equal to r squared, and we substitute. In place of x, we have 8, so 8 is squared is 64, plus y squared, and then 10 squared is 100. So we subtract the 64 from the 100, and we get y squared is equal to 36. And then we take the square root of both sides, and so y is equal to 6. Plus or minus? Well, that's where we have to go back and look at the graph. what is y over here? In this area, y is positive. Listen, 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 listen. You come up with the plus and minuses on the x and y by the quadrant that the graph is in. The quadrant. Whether it's up here, y is up here, y is positive. Y is down here, y is negative. If x is over here, x is positive. If x is over here, x is negative. You determine in trig the plus and minus of the x and y by where the point is. Not by, look back over here, not by what you've been taught in algebra. The square root of 36 you've been taught is plus and minus 6. That is not true. The square root of 36 is 6. You come up with the plus and minus by other means. All right, let's go back over to the graph and look at the second example that I want to talk about. And that is, we're given that this distance out here, the radius vector is 17, and y is 15. What we want to find then is this x distance. How far over here is it? All right, and while we're at the graph, I'm going to look at this one. Remember this one now, the 15 is up in here, the point's up in here, the x is over here. So the x is going to be what? The x is going to be a negative. Down here, what's the x going to be? Well, the x is going to be negative, and the y is going to be negative. Right? So we determine the plus and minus. We can already go in here and put the minus in here because we know x is negative over here. X is negative over here. And looking for y on this one, y is negative. All right, now let's go look at the arithmetic on it. So we're looking for the distance from O out to B. And we were given that the y was up 15 and the r out to the distance, radius vector, is 17. So we get x squared plus 225 is equal to 289. And so x squared is equal to, we come over and subtract that, and we get 64. We take the square root of that, and the answer is 8. So the square root of 64 is 8. The answer is 8. But that point was over to the left, so we put a minus there. You put the plus and minus on there from where the point is. Okay? It has nothing to do with the square root. You put the plus and minus on x and y's from where the point is. All right, let's look at the last example calculation of this picture. And we want to find OC. All right? Well, we know what OC is. It's this. What we're looking for is the y value. All right. Squaring. A minus square root of 10 squared. A minus times a minus is a plus. This will always be plus. These will always be pluses when you square something. Now, what is the square root of 10 times the square root of 10? Well, it's 10. All right. We don't know y, so y squared is equal to. Now, what is this? 2 times the square root of 10 times 2 times the square root of 10. Well, 2 times a 2 is 4. The square root of 10 times the square root of 10 is 10. So what this is 40. So when you square a number in front of the square root, this gets squared, and this just gets to be the number. Okay. So let's finish it out. And y squared is equal to 30. Moving this across and subtracting it. And so therefore y is the square root of 30. And then you put the minus on there because of where the point C is located. It's located down, so y is negative. All right, now let's look at the second page of the notes. Don't fade when you finish the tape. This triangle. All right, now let's look at what we want to learn, quadrants. This is considered to be quadrant 1. This is the way you'll usually see it. Capital Q and capital 1 here, an I. Quadrant 1. Now what quadrant 1 is all the x values are positive and all the y values are positive. So memorize that, or think. I'd like for you to reason it instead of memorizing things in trig. Just read. Quadrant 1 is x and y. Well, what is x over here? X is positive. What is y up there? Y is positive. So in quadrant 1, all x's are positive, all y's are positive. Quadrant 2. Quadrant 2. What would quadrant 2 be? What would be x's? Well, they'd be negative, and the y's would be positive. Quadrant 3. X's are negative, y's are negative also. Now, like I said, you can memorize this, and you better know it real well to use it. But quadrant 1, plus plus, quadrant 2, x is negative, y is positive. Quadrant 3, both negative. Quadrant 4, x is positive, y is negative. Quadrant 4, x is over here positive, down, negative. So know those. Quadrant 1, plus plus. Quadrant 2, x is negative, y is positive. Quadrant 3, both negative. Quadrant 4, x is positive, y is negative. All right, now let's look at some things dealing with this. The next graph on that page, we have the point P, which is 3, 4. X is 3, y is 4. And we're going to consider this to be the angle theta. The angle theta. Okay. The angle from the positive x-axis to the radius vector, we will consider that to be the angle theta. All right? Now, we have the point Q over here. Out. And that's, again, are those same numbers we used before. We're going to call it the minus 5, 3. But what I want to talk about now is we have this angle measured from the positive x-axis over the radius vector, and we're going to call that the angle phi, or phi, whichever way Greek pronunciation you want. Okay. So we have that angle, and then we're going to use that same point down here, that minus 2, minus 6 that we talked about before, and we're going to talk about this angle as being what we call psi. Right? Angles, the Greek letter psi, psi, pitchfork's what I call it. Okay. And then that point T that we had, which was minus 15, over here 8, and we're going to call that angle around delta, the Greek capital letter delta. All right, and if you notice in the notes, I'm saying this angle, I have an arrow pointing this way. Well, that's the same angle. We'll learn that in another chapter. But this is the angle delta for that, and this is the angle psi for that point. This is the angle phi for point Q, and this is the angle theta for point P. All right, now what we need to do is memorize. Memorize. We must memorize these 6 trig functions. 6 trig functions. Now, the sine of theta, the sine of phi, the sine of psi, the sine of delta, the sine of any angle. Now, we write it as S-I-N. The correct spelling of it is S-I-N-E. So don't call it sin of theta. It's sine of theta. This is called the cosine, C-O-S-I-N-E, the co-S-I-N-E. And then we have the tangent, T-A-N-G-E-N-T. We have the cotangent, cotangent. And you're going to learn some things, why those words are called co-functions and all that other stuff as you go through trig. Cotangent. And this is called secant, S-E-C-A-N-T, the secant of the angle. And then this is called cosecant. So you have 6 functions: sine, cosine, tangent, cotangent, secant, cosecant. Now, here are the relationships of the 6 trig functions related to the x, y, and r of angles. of points. So you must memorize. The sine of any angle is the y value over the r value. The y value over the r value. How far it is up or down over how far it is out to the point, the radius vector. The cosine is x over r. You just memorize that. The tangent is y over x. Oh, wait a minute, look. The tangent then is the sine over the cosine, isn't it? If I take this fraction and divide that fraction, invert and multiply, hey, I get that. Well, there's a lot of little tricks in here. The sine is y over r. The cosine is over r. The tangent is y over x. Or whatever the sine value fraction is over the cosine fraction. So if you know the sine and cosine, you could find the tangent by just taking that fraction, dividing by that fraction. Or taking this numerator over this numerator. Okay. You need to pick up on things like that and see those things and remember them. Okay, cotangent. The cotangent is x over y. Or look, it is the tangent flipped over. The cotangent is the tangent flipped over. So if you know the tangent to be 4 over 3, then the cotangent is 3 over 4. Okay? So those are flipped over. These are called reciprocals. Well, secant. Secant is r over x. Hey, look at there. That's the same thing as the cosine flipped over. So the secant is the cosine flipped over. So when you find the cosine of something, then you automatically have the secant. All you do is do its reciprocal. And then the cosecant is the sine reciprocal. Now, you need to learn it all. You need to just know secant. If you didn't know anything else, and the problem just says, what's the secant of that angle? Then you need to know r over x. But you also need to know, if you find the secant, you've found the cosine, because all you have to do is flip it over, reciprocal. If you go find the sine of something, hey, you have the cosecant at the same time. So you memorize and learn this before you go any further in trig. This is one of the most important concepts that you can use and learn in trig for other classes like statics for engineers and calculus classes and so on and so forth. All right, now let's look at using those numbers that I wrote on the chart. Let's come up with the 6 trig functions of each of the angles. Let's find the sine of theta. Well, if I were you, when you're first doing this exercise in this course, I would write down, every time I write down the sine of theta, I would put y over r. Don't just start putting the numbers down. Put down y over r. And just write that down every time you do the sine, just for the practice of memorization. All right, so the sine of theta is y over r. Y is what? 4. R is what? Oh, we have to go calculate it. So we'd have to do x squared plus y squared is equal to r squared. Well, x squared is 9 plus y squared is 16. That's 25 squared. That's 5. Now, that's what the other part of this tape, the beginning part of this tape, was all about, is if you're given some of these numbers, how do you find the other letter? All right, well, cosine. Cosine is x over r. Well, x is 3 and r is 5. What's tangent? Tangent is y, which is 4, over x, which is 3. Cotangent is x, which is 3, y is 4. Or, just flip this over. If you get one of them calculated, do the other one by calculating it, by flipping it over. All right, secant is r, which is 5, over x, which is 3. Cosecant is r over y. R is 5, y is 4. R again, flipping over the sine, flipping over the cosine. All right, now let's look at OQ. Now OQ is at point minus 5, 3. Okay, well, the sine is y over r. I'm not going to do this here, but you should on homework write down y over r. Well, what is y for the angle phi? Well, it's 3. What is r? Okay, well, r is 3 squared plus a minus 5 squared. And so that's what? 25, 34. So that's the square root of 34. Now that answer is sufficient. That answer is sufficient. But in the back of the book, our teacher may want you to write that as 3 times the square root of 34 over 34. A lot of them want you to rationalize the denominator. Don't leave a square root in the denominator, so you multiply the top. Nowadays with calculators, you know, if you're going to have to find that value somewhere, you just go do 3 divided by the square root of 34, get that decimal value, put it in memory, and keep it there, and you got it correct 8 or 9 or 10 decimal places. Okay, cosine. Cosine is x over r. Well, let's see. X was what? X is a minus 5 over square root of 34. Now, what I would like for you to understand is sometimes that minus is going to be out in front. So it doesn't make any difference where you put a minus in the top, in the bottom, or out in front. That means the same thing. I can put the minus there, I can put the minus there, I can put the minus there for a final answer. But the minus really goes with the x, so it's not bad to leave it there. Okay, tangent. Tangent is y, which is 3, over x, which is a minus 5. And again, you will see that written as the minus out in front. But you need to know that minus, does it go with this one or does it go with that one? Well, it goes with which quadrant? The tangent is negative right here. Well, in this case, the negative came from the x part because it was in quadrant 2. Okay, cotangent. Cotangent is x over y. Secant is r, which is square root of 34, over x, which is a minus 5. And cosecant is r, 4, over y, which is 3. All right, now let's look at OS. We're looking for the sine of psi. Okay. Well, sine is y over r. Well, y is a minus 6. And r was what? Well, we have to go through a minus 2 squared plus a minus 6 squared. And so this is the square root of 40. Now watch. What happens now is then that is 2 times the square root of 10. And that would then, this would be minus 6. And then this 2 would divide out. So you could see an answer in the back of the book of this being a minus 3 times the square root of 10 over 10. That looks weird. It doesn't look like that same answer, but it is by doing rationalized denominator. Okay, the square root of 40 is 2 times the square root of 10, and then I move the square root of 10 up here and put a 10 down there. I do that by multiplying the top and bottom by the square root of 10. And then reducing and all that stuff, and you get that. It doesn't even look like that square root of 40 in 6 numbers, but it is. So this is the same answer as this. Either answer is sufficient. All right, let's then continue with the cosine. The cosine of psi is x over r. Now what's going to happen here is when you finish, you're going to get a minus the square root of 10 over 10. Because this is going to be 2 times 10, and those 2's will divide out. And then the square root of 10 on the bottom is rationalized by the square root of 10 over 10. That answer is just as sufficient as this answer. Just know that they're the same. Know that when you see this, hey, that answer was correct. All right, then tangent. Tangent is y, which is a minus 6, over x, which is a minus 2. So the answer is a plus 3. Now, listen closely. What that means is this ratio, 6 to 2, is the same thing, as the ratio of 3 to 1. So when you see the tangent of an angle is 3, then that could have meant the sides of 3 and 1, or 6 and 2, or 12 and 4, or whatever. All right, cotangent. Cotangent of the angle is, just flip this over, 1 over 3. You've already worked it up here. This came out to be 3. So the cotangent's 1 over 3. Positive. two negatives make a positive. So in quadrant 3, these show to be positive. Secant is r over x. R was the square root of 40 over x, which is a minus 2. Now again, simplifying here, you will end up with minus the square root of 10. Because this will be 2 times square root of 10, 2's will divide out, leaves you square root of 10. Cosecant. Cosecant is square root of 40 over minus 6. So that's going to look like the square root of 10 over 3, negative. All right, let's do the last one now for the angle delta, for the point T, for the sine of delta is what? Sine is y over r. Well, the sine is a minus 15 over 17. Cosine is x over r. X is 8 over 17. Now let's forget about looking at the picture anymore and just go here. The tangent then would be what? Minus 15 over 8. Therefore, looking down here, now the cotangent would be 8 over 15, minus out in front. Now let's back off and look at cosine here. If the cosine is 8 over 17, then the secant is 17 over 8. And backing off, if the sine is a minus 15, then the cosecant is 17 over minus 15. Now, one more caution. I'm saying to you, learn this by all these tricks also. Tangent, cotangent, flip them over. Cosine and secant, flip them over. If you know the cosine, you got the secant. If you know the sine, you got the cosecant. If you know the cosecant, you got the sine. But then you must also know them just for a single one. More often in the application of this, you'll just run across what is the cosine of an angle when the x is 8 and the r is 17. Go find that. Go find that angle. You go take a calculator and punch buttons and you'll find that. And you'll learn that later on in another chapter. All right, now let's look at the last page of the notes. All right, let's look at some special angles that you deal with a lot of times throughout trig and other math courses that require trig. 0 degrees, 90 degrees, 180 degrees, 270 degrees, these special angles. What do we do in terms of x, y, and r? What's the sine of 0? Sine of 0 is y over r. Well, there's y, so we've got to calculate r. Well, r will happen to be the same as this number because this squared plus this squared is equal to this squared, and the square of that is this number. In other words, up here, x is 0, y is 4, and r will be 4. So I don't care what number I put on here, what point I put on here makes a number for y. If this is 0, 2, then r is going to be 2. If this is 0, 6, then r is 6. If r is going to be 8 up here, this would be 0, 8. So r is going to be whatever the number is of this ordered pair. Wait a minute, whoops, except r is always positive. So here, the y will be minus 1, but r will be a plus 1. Here, x will be a minus 1, but r will be a plus 1 because r, the radius vector, is positive at all times. All right, so now let's keep looking at that chart at different times as I talk about these, but now let's come over and do the sine, cosine, tangent, cotangent of 0 degrees. So let's look at 0 degrees, and 0 degrees is, looking at the graph, what is y? Well, y is let's see, y is 0 and r is 1. Cosine is 0 degrees, x is 1 and r is 1. There, let's continue this. Make sure we always finish this out. So this would then be 0 and this would be 1. That's going to be important here in a few minutes, knowing both of these now. You need to know that 0 means 0 over 1, or 0 over 5, or 0 over 10. But 0 means 0 over a non-zero number. All right, then cosine of 0 degrees is 1 over 1. Tangent is y over x. Well, y is 0 and x is 1. Well, that's also 0. All right. Cotangent is x, which is 1, over y, which is, and this is not possible. When you get a 0 in the denominator, then the answer to that angle is not possible. It does not exist. 1 divided by 0 does not exist. So we have no angle at exactly 0 degrees. All right, secant. Secant is r, which is 1, over x, which is 1, and so the secant's 1. Cosecant is r, which is 1, over y, which is 0. Oh, we have another not possible. All right, let's back off and look at all 6 of those. And I want you to notice something that's going to always happen. On 0 degrees, 90 degrees, 180, and 270, you're going to get 2 zeros. And when you get 2 zeros, that means you're going to get 2 not possibles. Because the 2 zeros that get flipped over put the 0 on the bottom. Get the 0 on the bottom. Therefore, those are going to be not possible. So wherever you get the zeros up here, their reciprocals are going to be not possibles. And the other 2 are going to be 1s or minus 1s. So you're going to get 2 zeros, 2 1s or minus 1s, and 2 not possibles on 0 degrees, 90 degrees, 180, and 270. All right, now let's look at 90 degrees. In my opinion, what you need to do is not try to memorize. You're going to end up memorizing 120 things if you try to memorize all these different angles and different things in trig. What you need to memorize is what I've been trying to teach you in this tape, and that is sine is y over r. Go find 90 degrees and look at what y over r is. Well, in this case, y is 4, r is 4, and therefore the answer is 1. All right, the cosine of 90 degrees. Cosine of 90 degrees, x is 0, r is 4, so the answer is 0. Tangent 90 degrees. Tangent of 90 degrees is y, which is 4, over x, which is 0, and so this is that not possible one. Now, let's learn to work from there. What is cotangent? If it's not possible, it's the 0 on the bottom, so when it switches, it's the 0 on top, and therefore the answer is 0. The reciprocal of 0 is not possible. The reciprocal of not possible is 0. Secant. We'll back off and look at all of them now. So the cosine is 0, therefore the secant will be not possible. Or in other words, 4 over 0. What's the cosecant? Well, what's the sine? The sine is 4 over 4, so the cosecant's 4 over 4 are equal to 1. And look again, we have 2 zeros, 2 not possibles, and 2 1s. All right, now let's look at 180 degrees. And let's just look at all of them at once. Okay. All right, here we go. 180, sine is, let's see, the y is 0 over 1. R is always positive, so that answer is 0. Cosine is minus 1 over 1, so the answer is minus 1. Tangent is, we'll go right here. Tangent is sine over cosine, 0 over minus 1, so that's 0. And now that we've got these three, we can flip them over. Cotangent is this flipped over, which would be not possible. Secant would be this flipped over, which is still a minus 1. Flip that over and you still get a minus 1. Reciprocal of a minus 1 is a minus 1. And then flipping over the sine, we get a not possible. And again, we have 2 not possibles, 2 zeros, 2 minus 1s. All right, the last one, let's look at 270 degrees. The sine of 270 degrees is, looking at those numbers over there, sine is y over r. Y is a minus 1, r is 1, so the answer is a minus 1. Cosine of 270 is x over r. X is 0. R is 1. Answer is 0. Tangent. Let's see. Tangent. Tangent is sine over cosine. So that's a minus 1 over 0, which is not possible. And cotangent's this flipped over, so it's 0. Secant is this flipped over, so it's not possible. And cosecant is sine flipped over, which is a minus 1. Again, notice 2 not possibles, 2 zeros, 2 minus 1s. Now, again, before I finish the tape, I want you to hear what I want you to know about this. Let's go back and look at the graph. So what I'm saying for you to know is if I want the sine of 0, then I just come over and look at this. Sine is y over r, 0 over 1, it's 0. If I want the tangent of 90 degrees, don't even fool with 4s. Just make every one of them 1s and minus 1s, because it doesn't make any difference. If you put a 4 here, you divide by 4. So we might as well use the smallest, easiest number to work with, which is 1s. So if I want the sine of 90 degrees, sine is y over r. There's y, r is 1. If I want the secant of 180 degrees, secant is r, which is 1 over x, minus 1. Answer is a minus 1. So to get the special angles, 0, 90, 180, 270, all you have to do is sketch that or put that mentally in your mind. And then know x, y, and r. And you have it rather than memorizing 24 different numbers. Okay, this concludes a statement, a single trig statement, and from that let's come up with the other 5, okay? Cosine, tangent, cotangent, so on. Given the sine of an angle is a ratio out here, or the tangent of some angle is a ratio, come up with the rest of them. Well, what they're saying is this is another way of giving us 2 of the 3 letters, x, y, and r. So what you should do when you're learning to do this, every problem I believe what you should do is to learn to write down. Okay? X equals, Y equals, R equals. Well, now let's go back up here. Sine of theta. Sine is Y over R. That must mean that's Y and that's R. Okay, well, let's see. Y is 2 and R is 7. Oh, wait a minute. Where's that minus go? Y and R. R is always positive, so the minus that goes with the 2. All right, and then we do x squared plus y squared is equal to r squared. So x squared, we don't know that. Y squared is 4. R squared is 49. And therefore x squared is 45. So x is the square root of 45. Now, hear this statement. The plus and minus on all of these come from the quadrant that it's in. From the quadrant that it's in. So let's go back up here and look. The sign is y over r, negative. That means the negative is for the y, which is third and fourth quadrant. So the angle is down here or here. It's in the third or fourth quadrant. Well, it says it's not in quadrant 4, therefore it must be in quadrant 3. And x in quadrant 3 is a negative value. All right? And that's how you work this. This is how simple this concept is. But listen to me again. What you should do when you're given a trig function in the ratio over here, you ought to write down, either mentally, you should do it on paper when you're first learning, x, y, and r. Well, I'm going to be blank. And then you go figure out the third letter by x squared plus y squared is equal to r squared. And remembering that plus and minus go on here for x and y's by the quadrant that the angle is in. And that has to be given. It has to be given for you to figure this out. In all trig, when you're working with trig functions, angles, you must be given 2 things. You must be given 2 of the 3 numbers and the quadrant that it's in or not in. Well, you finish this out then, and you can do this. I'm not going to finish it all out. Therefore, the sine of theta, we know that to be a minus 2/7. The cosine of theta then is a minus square root of 45 over 7. And then the tangent is a minus 2 over a minus square root of 45, which would be a positive, and so on and so forth. All right, let's look now at the next example. Looking at the next example, it says we're given that the tangent of theta is equal to a minus 24 over 7. Well, let's see. That says that x is equal to, y is equal to, and r is equal to. Tangent's y over x. So y is 24 and x is 7. And so we go through x squared plus y squared is equal to r squared, and so we get 7 squared plus 24 squared, and that's 576 plus 49 is 625. So r is equal to 25. R is, oh, wait a minute. Let's go back at the top and look at this again. This says that the tangent is a negative something. Now, we don't know where that minus goes with the y or with the x without some investigation. Well, look right here. This is what this is for. This tells us where we are, which quadrant. This says that the sine of theta is a negative. That means the sine is minus. Well, where is the sine negative? Sine is y over r, so y is negative, y is negative. This says that the sine is negative. So there, we're there. So we're in quadrant 3 and 4 from this statement. Now, this says that the tangent's negative. Where is the tangent negative? The tangent negative is when x is plus and y is minus, or x is negative and y is plus, or when they're opposite. The tangent here is negative, that's positive. Tangent here is positive. So this says quadrant what? 2 and 4. This says quadrant 3 and 4, and therefore our answer is quadrant 4. Well, if it's quadrant 4, then the y is the one that's negative. I'm going to go through it one more time because that's what you have to do, setting all this up. You have to go through all this mental process. And in my opinion, you ought to write things down. All right. Tangent is negative. Tangent is negative is in quadrant 1, tangent's negative is in quadrant 2 and quadrant 4, where they have opposite signs. Tangent is negative in quadrant 2 and 4. Sine is negative in 3 and 4. Therefore, the answer is 4. Quadrant 4 says x is positive, y is negative, so the minus goes with the 24. And that's how you go through the process. Finishing this up then, the sine of theta is y minus 24 over 25. Cosine is positive 7 over 25. Tangent, look how that works out. Tangent is minus 24 over 7. Sure enough, that's just the same thing we were given. Therefore, the cotangent is minus 7 over 24. And the secant is the cosine flipped over, so that's 25 over 7. And therefore, the cosecant is the sine flipped over, which is 25 over 24. All right, now let's look at the last example on this tape. All right. Tangent theta is equal to 5, 6. Tangent not in quadrant 1. Well, let's see. Let's go with x, y, and r. Let's see, tangent is y over x. So y is 5 and x is 6. And r we don't know. Well, we'll come down here and do x squared plus y squared is equal to r squared. So we have 25 plus 36 is equal to r squared. So r is the square root of 61. Okay, so we'll go back up here and put the square root of 61. Wait a minute. What's this for? What did they tell us? We already worked this. Didn't even read that. Well, it's got to be in there for some reason. Let's go back. This is positive. That means this could have been negative. We don't know for sure until we read this. This says that the tangent is positive. Let's go back. Tangent is positive, plus, minus. Okay. So here's where the tangent is positive, but it says not in 1, therefore we're in quadrant 3, therefore we must put minuses on the x and the y. What I'm saying over and over on this simple, short tape is this is what you need to know about trig functions. If they give you a trig function with numbers over here, then they are telling you what x, y, and r is. They will give you 2 of these 3 numbers. You can find the other one by x squared plus y squared is equal to r squared. But the plus and minus sign must come from quadrant. They must tell you somehow the quadrant that you're in. And the way they do this, this tells us 2 quadrants, then this eliminates one of them. Or tells us which one of those 2 it is. But we must get our plus and minus signs for x and y from the quadrant that the angle is in. Okay, a short tape, but important tape in terms of summing up this chapter 1. Zero. And while we're at the graph, notice the 270 is 0 and minus 1. Looking at these graphs now, you can look back on that and you can fill in what this x, y, and r is. So now for 180 degrees, fill in x is a minus 1, y is 0, r is 1, plus 1. R is always positive. Don't forget that. All right, now let's look at the notes underneath the graph, and I'll just do both of these at the same time before I go back to the graph. Sine of 180 degrees is, sine is y over r. That's 0. Cosine is x over r. R is always positive, so now we get a minus 1. Tangent is y over x. That's 0. Since this is 0, cotangent's not possible. Here's another way of why it's not possible. Secant is cosine flipped over, minus 1. R over x. Cosecant is r over y, not possible. All right, let's look at 270. The sine of 270 is y over r. That's minus 1 over 1. If you look at your graph and your notes, you notice what y is, what r is, what x is. All right, cosine of 270 is x over r. That's 0. Tangent is y over x. That's not possible. If that's not possible, cotangent is 0. Or if you want to do it this way, cotangent is x over y. That's that. Secant is cosine flipped over. Secant is cosine flipped over. So if I flip 0 over 1 over, it becomes 1 over 0. Not possible. Cosecant is sine flipped over. Minus 1 flipped over, still a minus 1. All right, now, these are useful, and they're used a tremendous amount of times throughout trig and throughout other math courses. So you need to know the idea of 0 degrees, 90 degrees, 270, and 180. Special angles where we deal with the numbers 0, 1, and 1, or sometimes it's a minus 1. This concludes now the part 1 of chapter 1. This tape should help you understand how to deal with the x, y, and r in all instances and understanding the idea of quadrants. Now, if you need some more help, the second part of chapter 1 tape
will be working the problems off of page 15 and 17 in your textbook.